Hi everyone, this is Mrs. Turigno, and this is the Chapter 3 quiz review for Algebra 1B students. This video is going to focus just on questions 6 and 7, because I think 6 and 7 are probably the hardest ones on this review. And I think once you see it, once you see me work through it, it's going to make sense to you. It's going to be one of those things where you totally get it when I do it, but you maybe wouldn't have thought of starting it that way on your own. So I'm actually going to show you two methods for doing this problem. I want you to watch both of them, but then I want you to really latch on to the one that makes more sense to you. Okay, so let's wrap our heads around what's going on in this problem. Here's what we have. We have Mariana's house here. And we have Stephen's house here. Okay? And Joe is traveling between them. So Joe is somewhere in the middle. Okay, that's Joe. If you thought my artwork was bad on the whiteboard, how nice is it going to be here on the iPad? Okay, and the total distance between the two houses is 60 miles. Okay, so I can take and kind of break the distance into two pieces. There's the piece that he's already traveled, and there's the piece that he has left to travel. Okay? Now it gives you two variables in this problem. And again, you could use X and Y. I'm going to stick with the letters they give you so that hopefully they make sense to you. It tells you that D is the distance from Stephen's house. Okay, so the distance from Stephen, and H is the hours he's been traveling. So, essentially, this D is this. It's the distance that he is away from Stephen. So I'm going to go ahead and label this D. Okay? And this is the tricky part, is figuring out how far he's already gone. Well, he's been traveling for H hours, and it also says in the problem that he's traveling at 35 miles per hour. So if he's going 35 miles an hour for H hours, that would mean that the total distance he's already traveled is 35H. Okay? If that doesn't make sense to you, think about this. If you're traveling 50 miles an hour for 2 hours, you would go 100 miles. If you're traveling 30 miles an hour for 3 hours, you would go 90 miles. You're just multiplying. So if you're going 35 miles an hour for H hours, 35 times H is how you would get how far you would travel. So now let's look at this. Do you see that this and this put together would have to make 60? That's exactly what our equation is going to say. Okay, our equation is going to say 35H plus D would have to equal 60. Okay, so that's what you want for number 6, is that equation. Okay. Now, number 7. Oops. Let's look that up a little bit. Number 7 is asking you if he's 5 miles away, so basically we want the 5 to be here, how many hours will it take him to get to the point where there's only 5 miles left? So that 5 is my D value, so I would plug in 35H plus 5 equals 60. Then I would subtract the 5, so I would end up with 35H equals 55, and divide. Divide by 35, divide by 35. I don't know what that equals. About 1.57. So that's about an hour and a half. Okay, so after 1.57 hours, he would only be 5 miles away from Stephen's house. Okay, let's look at the other method. Okay, this is what I would call method 1. And this one I'm going to sort of think of as one of those constant decrease situations. So remember, in the constant decrease, we had an amount we were starting with. We had an initial value. And then we had a rate of change that could be positive if it was increasing or negative if it was decreasing. Okay, so again, I'm going to give you sort of a diagram for this. Here's Mariana's house. Here's Stephen's house. Joe is starting here. Okay, he's starting at Mariana's. And the total distance still is 60. So our initial value, the initial distance he has left to go, because it's asking me about the total distance he has left, which is D. The total distance he has left to go starts at 60. And then as he moves, it's shrinking by 35 miles every hour, because that's how fast he's going. So every hour he's going to move 35 miles this way. So that total distance is shrinking by 35 miles every hour. That equation looks different than the last equation we came up with, but it says the same thing. I could rearrange it and make it look like the other equation. Okay, so either way they're going to work, and you're going to see that it works either way. This one's going to be a little bit trickier to solve, okay, because question number 7, so again, this is question number 6. This would be the answer to that. Okay, question number 7 says, after how many hours will he be 5 miles away from Stephen's house? So again, that's your D value. I'm still putting that in for D, because D represents the distance from Stephen's house. So I would say, I'll shrink all that for just a second. I would say that 5 equals 60 minus 35H. I would subtract the 60 from each side. This time I'm going to end up with negative 55 equals negative 35H. Divide by negative 35. Divide by negative 35. And again, I would end up with H equal to 1.57. Okay, so your answer comes out the same either way, but there's two different sort of schools of thought that you can go about it. You could think of it this way, where you're starting with a certain amount and decreasing, or you could think of it as it having two parts. That would be sort of that linear combination method that we talked about. So you use whatever way works best for you, but know that they're the same as long as you set them up correctly.